Listen, buddy, I need you to subscribe, because you never know who is going to need the services of a logic detective. These old bones thank you. I've been in the logic detective business for a lot of years, let me tell you, and I have seen a lot of cases. Arguments come through my office door in all shapes and sizes, and they all think they are special. They all want my attention. When I was first starting out, I would give it to them, and they sometimes surprised me. But now I have noticed something important, and I am going to share it with you. You know how human nature is the same everywhere. You know how everyone wants the same thing? Someone to hold and money to spend on the horses, or maybe a new car? Well, just as human nature is the same all over, so too are arguments the same. This I know from long experience. I don't mean that all arguments are literally the same, not at least when it comes to the details. Sure, arguments are like different suspects, always looking different on the outside, and there is always some new kind of evidence to consider. They all have their own story to tell, that is true. But I want you to look past all of that surface stuff, because underneath all those differences, most detective cases fall into just a couple of basic patterns, and arguments are the same way. Arguments are more the same than you would probably expect, but only someone with the relevant training and logic can really see this. I want you should believe me when I say this, because, like I said, I have seen a lot of cases and a lot of arguments. I am the fellow who always looks for the inference claim whenever a citizen is speaking. I think you know it by now. I am a professional logician. Now, the last time we met, we learned how to tell an argument from something that only looks like one. We learned that explanations and collections of statements of belief and expository passages and some other petty criminals are not really arguments, even though they may pretend to be. A real argument is a set of statements where someone is trying to prove a point, offering premises as support for a conclusion. A real argument is a set of two or more statements with an inference claim. But I am telling you nothing new when I say this. So now that you have earned your badge for spotting arguments and non-arguments, you may believe that you are ready for the big time. You may think that you are ready to go out on a case with me. Sadly, this is not true. I am sorry to burst your bubble. Spotting an argument is just the beginning of the investigation. What we really want to know is this. Is the argument any good? Is it solid? Or is it just smoke and mirrors? Is the argument playing bunco with you? Or is it the authentic, real McCoy? Answering this question is where the real work of logic begins. Now, as I have told you, I have seen a lot of arguments, but there is something else you should know. There are a lot of arguments out there. There are more than I have seen, an awful lot more. How many arguments are there out there, you may ask? I do not want to discourage you in your quest for knowledge and a logic detective's badge, but I cannot lie to you, since that would do violence to my professional ethics. So I will tell you how many arguments there are out there. Brace yourself. In fact, there are infinitely many possible arguments. Think about it. You can always add another statement, change another claim, invent another scenario. There's no end to the combinations. Perhaps later on, I will show you a formal proof that the number of arguments is infinite. But for now, I think your intuitions have developed enough to know that what I am saying is plausible. Now, suppose that I am correct and that the number of possible arguments out there is infinite. How could we ever analyze all of them? How could we analyze even a reasonable fraction of them? If we had to evaluate each argument from scratch, inventing brand new rules every time, the job would be impossible. It would be like Steady Freddy betting on the horses. Freddy always thinks the next race is the one that will make him rich, and even though he always loses, he keeps on steady as it goes, because there is always another horse race to bet on. You and I both know that his horse will never come in, not the way the odds are stacked, but he is a true believer. A detective couldn't solve crimes that way. Imagine if every case required inventing a brand new method of investigation. Fortunately, reasoning isn't chaos like the horse races. What if Freddy could actually bring some order to his betting? What if he could tell the bad races from the good ones? What if there was some general principle that he could apply so that he would always be in the money? Sadly, Steady Freddy has never found that principle, but there are such general principles in logic that guide how arguments work. And most of them are surprisingly simple. Even better, once you learn those principles, you can apply them again and again, so all of those infinite arguments can be analyzed using a handful of general principles. However, the first step in discovering those principles is sorting arguments into the right categories. And here I have a bombshell to drop on you, because it turns out that almost every argument falls into one of two basic types. Two kinds of reasoning, two kinds of inference, two kinds of cases. The first kind is called a deductive argument. A deductive argument is one where the person making the argument is claiming something very strong. They're claiming certainty. In a deductive argument, the arguer is saying, if the premises are true, then the conclusion must be true. No wiggle room, no probabilities, no maybes. Let me show you an example. It is an example you have already seen. All human beings are mortal. Socrates is a human being. Therefore, Socrates is mortal. Now that's a classic case. The arguer is claiming that if the premises are true, if all humans really are mortal, and Socrates really is a human, then the conclusion can't be false. That is, the author is claiming that the conclusion follows from the premises with absolute necessity. The way that it follows that if 1 plus 1 equals 2, then 2 minus 1 must equal 1. You might think that it is as necessary as it is that if today is Sunday, your Aunt Ruby is making apple pie, because no one has ever known Aunt Ruby to do anything other than make apple pie whenever it is Sunday. But I am telling you that it is even more certain than that. Now, listen closely to me when I say this. Whenever someone makes an inference claim of absolute necessity, that's the mark of deductive reasoning. The premises are supposed to guarantee the conclusion. If that is what a citizen is trying to do, then the argument is a deductive argument, and deductive arguments are the first of the two types of arguments out there. Here's another example. All squares have 4 sides. This shape is a square. Therefore, this shape has 4 sides. Same structure, same kind of claim. Now, you might imagine that we are talking about Lenny the Rat's brother Larry, because he really is a square. But I do not know if he has 4 sides. But do not mistake me here. The shape called a square has 4 sides. So if the thing in front of you is a square, it has 4 sides. The author of this most perspicacious argument intended the premises to support the conclusion with absolute necessity. That is, again, the inference claim is one of absolute necessity. Now, some arguments are evildoers who try to fool you, because sometimes the author of an argument can fail to achieve what they intend. What do I mean? Well, consider this argument. All cats are mammals. All dogs are mammals. Therefore, all cats must be dogs. Now take a long look at that. Both of those premises are true, but they do not support the conclusion. This is not a good argument, but that is not what we are really interested in at this point. The question I have for you as a novice logic detective is this a deductive argument? I will pause for a moment while you contemplate your answer. So did you say that it is a deductive argument? If that is what you said, then you are correct. The author intended the premises to support the conclusion with absolute necessity. Of course, the author failed, but that does not make it any less of a deductive argument. It is just a bad deductive argument. If you have now inferred that there can be good and bad deductive arguments, and that what makes an argument a deductive argument is the author's intent that the premises support the conclusion with absolute necessity, then I take my hat off to you. You are indeed a very promising candidate for the logic detective license. A deductive argument is like a case where the prosecutor thinks they have airtight evidence, where they believe that the facts are in and the case is closed. The prosecutor can be wrong and lose the case, of course, because a bad deductive argument is still a deductive argument. So now you are a wise guy like me and know what makes an argument a deductive argument. But not all arguments are deductive. Sometimes the evidence points toward a conclusion without proving it completely. Sometimes the best we can say is that the author intended the premises to support the conclusion in a way that would make the conclusion only probably true. That's where the second type of argument comes in. Such an argument is called an inductive argument. In an inductive argument, the inference claim is not one of absolute certainty. It is a claim of some probability less than 100% certainty. The citizen arguer isn't saying the conclusion must follow. They are saying that they think the premises make the conclusion more likely than not. But I suspect you would like some examples. Good. Let me give you an example. Every swan I have ever seen has been white. Therefore, all swans are white. For centuries, people actually believed this, and given the evidence they had, it made sense. Every swan anyone had ever observed was white, unless they lived in Australia, because in Australia, there are black swans. Perhaps you did not know this. If you did not, I am glad that we have had this chance to talk, because black swans are a real thing, just like a 4-horse accumulator is. Are you telling me that you do not know what a 4-horse accumulator is? If that is the case, then I must refer you to Steady Freddy, who will be glad to provide you with an extensive dissertation on that very topic, just before he hits you up for the loan of a $5 that you will never see again. But let us get back to the swans. Notice that the premise, which says that all observed swans have been white, does not guarantee the conclusion that all swans are white. It does provide support for that conclusion, but it does not make it necessarily true. Why not? Because there might be a black swan somewhere, and in fact, as it turns out, there are. In Australia, as I mentioned, where everybody walks on their heads, or so I hear, which means that the inference claim made in this argument was not one of certainty. It was only one of some probability less than 100%. Such an argument is not deductive, so we need a different name for it. If you consult your logic detective's handbook, you will discover that an argument with an inference claim of some probability less than 100% is called an inductive argument. But I know, now you will be wanting another example. I shall oblige you. Here is another example. The sun has risen every day in recorded history. Therefore, the sun will probably rise tomorrow. Now that sounds pretty convincing, but logically speaking, it's still a probability claim. The citizen who has made this very interesting argument has only claimed that the premise makes the conclusion very likely, not that the premise makes the conclusion absolutely certain. After all, with the way things are going in the world these days, it is possible that our green and blue globe will stop turning and the sun will not rise. That is the way with inductions. They never promise certainty, only that something is likely true. Now, let me just give you one more inductive argument, but this time it will be a bad one. I have noticed that every time I meet Biff the Stiff while walking on the street, it starts to rain. I therefore conclude that the next time I meet Biff the Stiff, it will probably start to rain. This is an induction. I am only claiming that the many times I have met Biff the Stiff walking down the street, it has rained. And this is really true. I have come to believe that Biff the Stiff is a sad cookie indeed. But does this support the claim that it will rain the next time I meet him walking down the street? No, it does not. Not very well anyway. It is a probabilistic argument, so it is an induction, but it is a bad induction. Although I am of the belief that Steady Freddy would take it as a sign and go for that 4-horse accumulator. Now, my good friend, I want you to believe me when I say that inductive arguments are to be found all over the place. In weather forecasts, medical research, scientific experiments, even everyday reasoning. If your car won't start 3 mornings in a row, you might conclude the battery is dying. You are not absolutely certain, but the evidence points in that direction, does it not? That's inductive reasoning at work. So here is the key difference between deductive and inductive arguments. Deductive arguments claim certainty, while inductive arguments only claim some probability less than 100%. The inference claims are different, and that difference matters because once we know which kind of argument we're dealing with, we also know how to evaluate it. Why is this? Because all arguments fall into one of these two classes, and because deductive arguments are judged one way, while inductive arguments are judged another. And now I am done with you for today, so be sure to record all of this in your notebook and review it before our next case. Until then, when an argument walks through your door, do not be fooled by it, or you will lose more than the money you lost to Steady Freddy. Keep an eye on those inference claims, and make a note. Is it deductive or inductive? What are the perpetrator's intentions? Certainty, or only some degree of probability less than certainty?